The purpose of this video is to talk about how to graph with accuracy some points for the function g of x equals -3 times x minus 1 squared plus 6. This is a quadratic function, and it's quadratic because we have a squared term for our x values are all going to be squared, so that's why it's quadratic. So you will recall the following equation, which is a general vertex form of the quadratic function. This is the general form. And you may recall that the vertex is the point, it's a point on the graph, hk. Okay? It's basically taking your parent function and translating it to the right x and up k. Okay, sometimes h and k can be negative, but the other thing is the axis of symmetry, which is the point, the line that defines the symmetry of the quadratic function, is going to be the line x equals h. Okay, so for our function, let's go ahead and find the vertex of g of x. That is going to be, well, h is 1 and k is 6. So it's going to be the point 1, 6, which is, well, here's the origin. We're going to go over 1 and up 6. 1, 2, 3, 4, 5. Oops, I didn't go up 6. Need to go up 6. It's going to be this point right here. 1, 2, 3, 4, 5, 6. Okay. So that is our vertex. That's either a maximum or a minimum. And then we're going to find what we call the axis of symmetry. And all that is a line. It's an imaginary line, but it's a line that is x equals h. And in our case, h is 1. So it's going to be this imaginary line that sort of defines where this function is symmetric. Now we might want to plot a couple more points before we really know what this graph looks like. So in fact, if I want to draw a table, I'll just draw one over here. My x value and my g of x, or y value, are the points I'm plotting. So for instance, my vertex, I already know if I plug in 1 for x, I am going to get 6 out. For instance, if I take g of x and I plug in 1 for x, I'm going to get, sorry, I should probably put the 1 in for x in red. Okay, this is simply going to be -3 times 0 plus 6, which is just 6. So that's why I've written a 6 over here. This is why it's the vertex. Okay, because when you plug in that x value, you'll get the y value of that vertex. Okay, but let's say I want to take an easy point. Okay, let's say I want to just plug in 0 for x. Well, let's go ahead and do that. We'll do it in green maybe. So we're going to plug in 0 everywhere in this function where there's an x. Okay. Oops, did I not plug it in? I should plug it in. I'm going to replace that x with a 0. And what I find is -3 times, well, 0 minus 1 is just -1 squared. And that's just going to be, oh, let's see, that's going to be -3 times 1, because -1 squared is just 1. And -3, well, -3 times 1 is just -3 plus 6. And that's just going to equal 3. So if I plug in a value of 0 for x, I'm going to get 3 for y, and that's the point right here. Okay, that's what we call the y-intercept for this function. It's an easy point to plot, and we really do have to plot extra points to figure out what this graph really is going to look like. Okay. So one other point of interest, actually, this graph is sort of forming a U, but it's an upside down U. Doesn't look like our absolute value function. Okay, starting to have this shape of a U. So we need to know what's going to happen somewhere else, some other accurate point. Well, guess what? This axis of symmetry right here tells us that there's another point equidistant from the axis of symmetry, and that point is going to be right here. Oh my gosh, that's awesome. Cool, we don't have to do a lot of work. We can just graph right through it. What is that point? Oh, it's where x equals 2. So let's go ahead and take G and plug in 2 for x. We should get 3. Let's check it. That's going to be negative 3 times, well, let's plug in the 2, minus 1 squared plus 6. That's going to equal negative 3 times 1 squared plus 6, which is going to equal negative 3 plus 6, which is going to equal 3. Yes! So if we plug in 2 for x, we're going to get 3 out for g of x, or y. So I know this is looking like a v, but it shouldn't. This is more what it should look like. It should look like an upside down U. Here's the vertex at 1, 6. We have our axis of symmetry, which shares the x part of the vertex, right? It's just the line x equals 1. And then we have a y-intercept right here. So this is a way we can graph with accuracy. We'll talk a bit more about finding the x-intercepts in a little while.